Hey everybody, how's it going? Hope you're having a wonderful day. My name's Jose, and I'm a lighting console programmer here in Los Angeles. Today I want to talk about what is an IP address. Let's get to it. So first, I want to talk about the TCP IP protocol. That is the Transmission Control Protocol / Internet Protocol. It's a computer language with a set of rules that govern the communication between computers through the World Wide Web. We use this every time we visit our favorite websites. And the lighting industry uses this protocol as its infrastructure to be able to communicate from lighting consoles to media servers to wireless access points and to nodes. And an IP address, an Internet Protocol address, is a unique number that identifies a computer's connection to that network. Today I'm talking specifically about the Internet Protocol version 4. Let's take a look at an IP address. So here we have one, an IP address of 172.16.1.15. So it's made up of 4 numbers ranging from 0 to 255 separated by a dot. That's it. 4 numbers ranging from 0 to 255 separated by a dot. Now an IP address doesn't work alone. We use a subnet mask with it. And a subnet mask breaks that IP address into a network ID and a host ID. A network ID being the specific network that IP address belongs to, and the host ID being the unique number we give that specific device. That subnet mask has 3 different versions of it. There's a Class A, a Class B, and a Class C. So in a Class A subnet mask, we have a 255.0.0.0 scheme. In a Class B, we have a 255.255.0.0 scheme. And in a Class C, we have a 255.255.255.0 scheme. And what does that mean? What that means is that when we see a 255 in that octet, that number, that specific octet in that IP range needs to match between devices in order for them to communicate properly on the network. Here, let me show you what I mean. So once again, an IP address is made up of 4 octets, and it also comes with a subnet mask, which breaks down that IP address into a network ID and a host ID. So if we look at the Class A list that we have here, all we need is the first octet to match in order for these devices to communicate on the network. So if we look at this list, we notice that the first octet is the net ID. They all match, and all those other numbers can now be unique host IDs for those individual devices. That network is a good network. Let's look at our Class B. We have a 255.255.0.0 subnet scheme, so the first 2 octets need to match in those IP ranges for those devices to communicate with each other. If we look at the net ID 172.16 on all those devices, those 3 devices have the same net ID, so they will talk on that same network, and they have unique host IDs, so we have a good network. Now let's look at the last one, a Class C subnet scheme with a 255.255.255.0 subnet scheme. So that means the first 3 octets need to match. And if we look closely, that third one doesn't look the same. It's a 10 in the first number, but that second number being a 10, that second octet being a 10, doesn't match the rest of them. So that third piece of equipment there probably won't talk properly with our network. So the first 2 devices will, the last one, not so much. Let's look at a real world example here. So for our purposes, the lighting console is usually the thing that's putting out a lot of this data to our lighting network and our entertainment control. So we choose, as the operators, we choose an IP scheme that's going to work for us. Here we chose a Class B subnet scheme, being the 255.255.0.0 scheme. We chose that, meaning the first 2 octets need to match between all other devices to be able to communicate with our lighting console. So we have a unique host ID on our lighting console of 1.2. Now, if we look at the Ethernet node on the top right, it has the same net ID. Those first 2 octets, they match. So it will communicate with our console, and it has a unique host ID. So those last 2 octets. So this is a great device. It'll work properly. Everything's great. We look at our wireless DMX, same thing. We have the same net ID. Those first 2 octets, they match. And our last 2 host IDs are unique, so they will also communicate properly. That's a win. Now, if we look at the bottom node, we have a fail going on. Do you know why? Well, we have the same subnet mask, but our first 2 octets, that's right, they do not match, meaning they will not talk properly with our lighting network. So I hope that helps demystify some of those things that we don't understand about IP addresses and subnet masks at that, how important they are together. So thanks for watching. Hope you learned something.